Okay, so if we change these ones to radians, you'd basically multiply by pi and divide by 180. Now, so if we went 360 divided by 180, it's 2, and then we'd add a pi. This would be 0, so it'd be either 0 or 2 pi. If you do 90 divided by 180, you get a half, so you get pi over 2. If you do 180 divided by 180, you get 1, so that would just be pi. And then 270 divided by 180, you get 3 pi over 2. Now the catch with radians, and we'll go over degrees to radians, degrees way more in depth in like a lesson, but the catch with radians is you don't actually have to write radians behind it, right? You can just leave the number. So they can write it as 3 pi over 2, then you know it's radians. Or they can write rads behind it, or they can write radians behind it. All of those mean radians. But the way that you have to write degrees is you have to have the degree symbol. So if a number doesn't have a degree symbol, it's assumed to be radians. So if you see 2 degree symbol, it's degrees, right? But if you see 2 with nothing behind it, it's radians. So that's why it's extremely important to put the degree symbol when you're doing your answers. Because if you don't put the degree symbol, we're assuming it to be radian measure. Is he running? Am I recording this? I am. This is so awesome right now. Okay, so if it's a positive rotational angle, you go to the left. So always write your first arm where you start. So this would be called the initial arm. And then you have to draw the other arm because they need to go from an arm to an arm, right? To know where the degree is going. So if I wanted to draw 135, I would draw the arm halfway through here, and then I would draw my angle. And then I would say this is 135 degrees. So I have to draw my initial, I have to draw my terminal, and I have to draw which way I'm going, right? So I know that that's actually in the positive direction. Whenever you go in the left, it's in the positive direction. Now, can you convert that to radians for me? Use your calculator, convert to radians. And please never give a rounded decimal unless it asks you radians to the nearest hundredth or something. And why would it ever do that? Why would it ask for the nearest hundredth or something? Because that's just silly, because that's rounding, and I don't like rounding. Why would they ever do that? Numeric response. Okay. So what do you get in radians for 135? 3 pi over 4. Because 135 divided by 180 reduces to 3 over 4. Now, some people will say, how would I know what to use? Well, if it says degrees, use degrees. If it says radians, use radians. Or there's that restricted domain that we always give you. So like between 0 and 2 pi, well, then you would know your answer needs to be in radians. Or if it's between 0 and 360 degrees, then your restricted domain is between degrees, then your answer needs to be in degrees, which will come up sooner. So negative rotational angle, same deal. Except we're going to go in the negative direction, which is clockwise. So we start at 0 degrees. Then here's negative 90 degrees. And here's negative 180. Negative 270. Negative 360. So if you go clockwise, you get negative angles. Now in radian measure, this would be 0 radians. This would be negative 2 pi, because 360 divided by 180 is negative 2. This would be negative pi over 2. This would be negative pi, because negative 180 divided by 180 is negative 1. Negative 270 divided by negative 180 is negative 3 pi over 2. And then negative 2 pi. Yeah. Because they're going to ask you for answers in negative spots. So up to last year, when you guys did it and you even went more advanced, you would go from 0 to 2 pi. Then they ask you for only the solutions between them, because you know sine maybe you don't. But a sine graph just looks like this, and it keeps going on forever and ever. It's a periodic function. It just goes bloop, 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 to negatives and to positives forever. Okay? And last year, it does the bloop, bloop, bloop. Yes, it does. So yours last year, for the most part, was restricted between 0 and 2 pi, sometimes 0 and pi, something like that. So it took this graph that just keeps going on forever with like all these little hills and valleys, right? And I restricted it. Because if I didn't restrict it, you'd have to give me general solution, which we're going to do this year, which are all the solutions in the world that could possibly all be on that graph, because we keep going on forever. So now instead of restricting it between 0 and 2 pi, which is just a tiny portion of the graph, we could restrict it between negative 2 pi and 0, or negative 2 pi and 2 pi, or negative 4 pi and negative 2 pi and not even touch a positive angle. So last year, we just didn't push you into the real hard stuff. We put you into the 0 and 2 pi just to get you to do that. But there's a whole bunch more solutions in the world on that graph. We're just squishing you into a small piece. And we did positive because it would be easier. Okay? Even though that's still more than you really would have to in a lot of the cases. So in this case, if I wanted to do negative 135, it would be 45 more than negative 90 and 45 less than negative 180. So it would be here, which some people just draw me an arm there. Well, that can mean so many things. Just a random arm just drawn in the middle. Is that like a positive rotation this way? Is it a negative rotation this way? What is it? That's why it's important that you draw your initial, starts on the 0, and you draw your arrow. Hey, I'm going from that initial arm to this one. Oh, that's negative 135. Or it's negative 3 pi over 4. Now I could leave it as 3 pi over 4, like I did up there, or I could write rads behind it, or I could write radians behind it. All of those mean radians. So the terminal arm is where the angle ends and can be on any quadrant or on any axis. So where it ends is your terminal arm. It's where it terminates, where it ends. Okay. Sketch each of the following. This needs to have a degree on it because that would be really fun to draw 340 radians. Good luck. Godspeed. That'd be terrible. As a degree. Draw the degree. Do you see how important it is to have the degree? Because if it doesn't have the degree, that's a radian, and that changes the whole ballgame. So try and draw these out. See how you do. So the first thing I always suggest, and in standard position just means starting at 0 and going to wherever the heck you need to go to. That's all standard position is, okay? I would suggest that you label your axis because that makes life a lot easier. So 0, 90, 180, 270, 360. So 40 falls between 0 and 90. 45 is halfway in between, right? Because every single one of these angles are 90. So 40 is a little bit less. So we're going to go from here to a little less than 40. Or almost, it looks like 45. But pretend it's not. That's 40 degrees. And we have 0, 90, 180. So 140 falls about 40 less than 180. So I'm going to draw it about 40 less than 180. And then I'm going to go from here to here. I have to make sure I draw my initial arm too. So that's 140. Then we have negative 240. So I'm going to label them 0, negative 90, negative 180, negative 270, negative 360. Now you could look at this two ways. You could say 240 is 30 less than 270, or you could say 240 is 60 more than 180. Whichever way you look at it is fine. I'm going to say it's 30 less than 270, so it's about here. And then here's my initial. And the arm has to go like this, backwards, because you're going clockwise. When you go clockwise, you're going negative. So negative 240. And then 340 is in the positive. So I start here, and then I go about 20 less than 360. That might not be 20. That might be an underestimation. 340. And if you draw a full circle, it's 360, so it makes sense, right? Okay. So here's that radian measure. So this is the big thing here. To convert from degrees to radians, multiply by pi over 180. So that's that Dr. Pot. Degrees to radians, pi on top. Some people like RD-POB. I'm not quite sure, but if you really want to do RD-POB, go ahead. If not, I just go degrees to radians, pi on top. So the other one, the pi must be on the bottom because it can't be on top. Okay? Some people just remember from degrees to radians, I have to divide by 180. So the pi must be on the top. So it's up to you. Whatever way you want to think about it. Ooh, these are fuzzy. So, convert from degrees to radians. Answer in exact value. If it's exact value is never decimal, guys. Exact value, unless it's a terminating decimal, that you could say is an exact value technically, but you have to put it in a fraction with a pi. Then here I want you to do the nearest tenth. I used to not make people go to the nearest tenth and stuff like that, but then I realized people don't know how to turn it into a tenth with a pi in it. Okay? And you need to for numeric response. That was hard. So 270 times pi over 180, because degrees to radians, pi on top. What does that reduce to? And by the end, you'll have these memorized. You won't even be doing them. 3 pi over 2. Because just 270 divided by 180 reduces to 3 over 2, right? You add your pi. 315. So we're going to multiply by pi over 180. 315 divided by 180 reduces to what? 7/4. So I can write my 7/4, but what do I have to make sure I add? The pi on the top. Everyone's really good at that. Then I get to the next one and people like fall apart a bit because they're like, I don't know what to do with that pi. Just put it in. So literally when I want it in nearest tenth, you just go 70 pi over 180. You're just going to go 70 times pi divided by 180. What's 70 times pi divided by 180? To the 10th. 0.4? You agree? You disagree? You're all giving that face. I don't know if that's an agreeing face or a non-agreeing face. It's agreeing? Okay. Your faces look the same all the time. Your eyes just get wider or not as wide. It's really fun reading your faces. Okay, 205 times pi over 180. See? I can tell by your faces, and then you're all like, no, it's good, it's fine. You guys all get quiet and your eyes get wider. No joke. Your faces do not change. You just get all quiet and then your eyes start looking at each other like, is someone going to say something or is it just me? Because heaven forbid we tell like that it's me and then I was actually wrong because then I corrected the person but I was wrong and then it just starts falling apart in my eyes and oh, I saw it in your eyes. Oh, you people. So what is it actually? Oh. Okay. 205 times pi over 180. 3.6. Perfect. So converting from radians to degrees, you multiply by 180 over pi. If there is a pi in it, it's wonderful because the pi's just cancel. If there's not a pi in it, you're going to have to deal with it. That's in the next example. So this pi and this pi cancel, and then you get 180 divided by 4, which is? Thank you. 45 degrees. You need to have the degree symbol or it is not degrees. It will never be degrees. It is not degrees. You'll be wrong. You'd be like, but Lepp, I just forgot the little degree symbol. It's huge, huge. A little degree symbol means it's not degrees if you don't have it. So that's a problem. Yeah. No, because you have to put the pi in order to give me the actual answer. And this happens when it's a numeric response. And the reason why is we push exact values so much because you really do need exact values. But then when it comes to numeric response and they give an answer, I find that people give the wrong answers because you guys don't know how to turn them into decimals because we like slam you with exact values so much. So yes, you have to put the pi in or else you're not actually giving the decimal format of it. Okay, so then this one we're going to times by 180 over pi. The pi's cancel. And what's negative 7 times 180 divided by 3? Negative 420 degrees. That's a bad degree. Okay. Now, when it's 1.57 radians, I could have literally just put 1.57 as well, right? That's radians. Is there pi to cancel? No. So you're going to go 1.57, so times 180 over pi, because that's how you convert from radians to degrees. So you're literally just going to go 1.57 times 180 divided by pi. That's it. You have to put it in because I want it to the nearest 10. So what's 1.57 times 180 divided by pi? Anyone get it? 90.0? Oh, proper rounding rules makes that 90.0. It does. Now, this will be my little fight again. But Mrs. Lepp, 90 and 90.0 are the same thing. They technically are the same number. I will give you that. Well, I don't know why I'm doing this. There you go. But that is not to the nearest 10th. The nearest 10th is how many decimal places? 1. And remember in junior high when they would be like, round to the nearest 10th. Where's the 10 spot? Where's the 100 spot? Where's the tenths? Where's the thousands? Where's the blah, blah, blah? If you just give me 90, you are not giving me the 10th spot, and your junior high teacher would be super sad with you in grade 7. Okay? Not very happy. So don't be that person. Plus, you're wrong. Okay. So negative 1.4 rads, so you times it by 180 over pi. And we get negative what for degrees? Okay. These type of questions, the next ones, kind of sit in their own little trig bubble. They're arc length questions, and they're the very top formula on your formula sheet, and they really don't kind of work with the rest. It's that theta equals A over R formula. So it's theta equals A over R. A is always your arc length. What the heck is an arc length? Well, if I'm looking at a circle and I'm looking at a piece of the pie like this right here could be my arc length. Or I could be looking at the outside of it and this could be my arc length. Depends on what they're looking for, right? So those pieces are the arc length. Okay? R is the radius. So sometimes they trick you out and they give you the diameter. The diameter is just what? The radius. 2 times it, so the radius is half the diameter. So here's your radius. The catch is these have to be in the same units. So if one's in centimeters, the other one has to be in centimeters. They don't make you convert or anything for that matter, usually. But if you're trying to find the radius and they give you the arc length is in centimeters, then your radius answer would be in centimeters as well. This is the huge thing that messes people up. That's your angle, your central angle. So if they gave me this central angle, I'd be looking for this arc length. If they gave me this central angle, I'd be looking for that arc length. Okay? The central angle has to be in radians. So when you go to fill it in, if you fill in degrees, you'll get the wrong answer and it will be on your diploma. It will be on your unit test. It will be on your cumulative exams. Okay? So what will they do? They'll either give it to you most of the time in degrees, make you convert it to radians and then solve, or they'll ask for your answer for the central angle. They'll ask for it in degrees. Well, when you solve it with the formula, you actually get it in radians, so you have to convert it to degrees. Okay, that's how they get around it. Okay, so let's look at this first one. A pendulum 30 centimeters long. So we have a pendulum, and it's 30 centimeters long. 30. Oh, it's just getting worse. Swings through an arc of 45 centimeters. So that arc is always the bottom outside part, right? That's the arc length. So it swings through an arc of 45 centimeters. And then it can join up here, right? Here would be your pendulum again. So through what angle does it swing? So we're going to find this part because that's the angle that it's swinging through, right? We're not going to look for the outside portion of it. If we needed to find the outside portion, we could find this angle, change it to degrees if we really wanted to, and then what would this outside angle be? How could we figure it out? 360 minus it, yeah. Or you could leave it in radians and do 2 pi minus it, right? Because 2 pi is the same as 360. Okay, let's figure it out. Oh, look, they want the answer in degrees. They want it in radians too because it's my type of question. But if this was a question on the test, I probably would ask for it in degrees because your answer is actually going to be in radians and then you're going to have to convert. So theta equals A, which is 45, over R, which is 30. What's 45 divided by 30? 1.5 what? Radians. Now, like I said, people forget about that. So we have to go radians to degrees. So if we do radians to degrees, pi is on bottom. And you have to include the pi because they want it to the nearest, or answer in degrees, and radians to the nearest tenth. So what's 1.5 times 180 divided by pi? 85.9? And then I walk away from this question and I'm wrong. Degree symbol. Calculate the arc length to the nearest tenth of a meter. So we're trying to find the arc length. So we're trying to find A. Of a sector circle with diameter. Diameter just gives me what indirectly? Radius. So radius is half of that. So 9.2 meters divided by 2 is 4.6 meters. And the sector angle is 150. So a lot of people want to label it right away. I wouldn't label it right away because that isn't theta. That's a version of theta, but it's not theta. Theta has to be in radians. So theta actually equals 150 degrees times pi over 180. And 150 divided by 180 is 5 pi over 6. And now we can actually do the formula. So the formula is theta equals A over R. Some people like rearranging the formula beforehand. You can do that. I just input the values and then rearrange after. It's up to you. Both work. So theta is 5 pi over 6. And it equals the arc length over the radius, which is 4.6. And this is together, so I'm going to put it in brackets. I just made that look bad. So I want to get A by itself. A is being divided by 4.6, so what am I going to do? Multiply. So what's 4.6 times 5 pi divided by 6? What do you get? To the nearest tenth. Sorry. What? 12.0? 12.0 meters, because the units have to be the same, right? Make sense? Then we do coterminal principal reference angles. Okay? Coterminal angles are angles with the same arm. Principal angles are the smallest positive rotational angle, coterminal with a given angle. So principal angles are usually your angle between 0 and 360. Okay? Or coterminal we'll explain when we get to them. And then reference angles are the acute angles between the terminal arm and the x-axis. What does that mean? Well, that means, don't know why I'm drawing a circle. That means if my terminal arm is here, okay, let's say, and this was a 45-degree angle, then my reference angle would be 45 in this case. Because it's always the angle from the terminal arm to the x-axis. Well, when it's in quadrant 1, that is the angle. When it's in quadrant 2, say I give you 160. My reference angle definition is the distance, or the angle, from the terminal arm to the x-axis. What would it be in this case? I hear people saying it really quietly. 20. So it would be right here, which is 20. So this one would have a reference angle of 20. So the only one that has the same reference angle as its angle is the one in quadrant 1, right? So we'll go through a few. So it says, all right. Back. Sketch the following rotational angles and give the reference angles and give 2 coterminal angles. Okay. So we'll do the rotation angle, reference angles first. Coterminal is actually really, really easy. Okay. So the first rotational angle is at 60. So I have 0, 90, 180, 270. I will label these every single time because it makes my life a heck of a lot easier. Okay. So 60 degrees is 30 from 90. So I'm going to draw it. What am I doing? Drawing it like crazy people. That's what I'm doing. Okay. So that's 60. We agree? What's my reference angle? 60. Now, I'm going to do this way down here, so bear with me. Okay. Just pay attention. You don't need to draw this. So I have a 60-degree reference angle and a 60-degree angle, right? Coterminal means it terminates on the same arm. So how could I find another angle that would end up on that exact same arm? So if I kept going around and I came back to that spot, it would terminate on that arm, wouldn't it? A full circle is how much? 360. So if I just went 60 plus 360, what do I get? 420. So if I do 420, 420 would be a whole 360. So if I went to go do 420, it would be a whole 360 around plus 60 more. Would it terminate on the same arm? Yes. So could I do that again? Could I do another 103 or do another 360 onto 420? Yes. So if I went 420 degrees and I added 360 to it, I would get 780 degrees. Make sense? Could I go the opposite way? Yeah. If I went 60 and I subtracted 360 from it, I would get negative 300. Does that make sense? Negative 300 working around, would that land on that same arm? Yeah. So I could go 60 minus 360, and I would get negative 300. And all of these are coterminal with 360, or with 60, not 360, 60. Does that make sense? So you just have to add 360. So if it's radians, instead of adding 360, what would you add? 2 pi. Okay? So that's your difference in coterminal. And I don't know why it did this. It changed some of my things to this. In the conversion. Great fun. Okay, so if you have 5 pi over 3, and you don't even know where the heck that is, okay? Could you convert it to degrees, do it that way, and then convert back to radians your answer? Absolutely. Now, I like to push just sticking to radians if you're in radians, but what I found is students do not like that, and they therefore do not listen to me, and they just convert it to degrees anyways. As long as you have the same answer, it doesn't matter which route you go. So I'll convert it to degrees because that's usually what people do anyways. So you go 180 divided by pi. The catch is, though, that the question was in radians, so your answers have to be in radians. It doesn't matter that you convert them to degrees. So in the end, you'd have to convert back. Okay? The pi's cancel. And what's 5 times 180 divided by 3? 300? So 300 is going to be around, and then 30 more than 270. What's my reference angle? 60. You will learn to memorize some of the radians. You will. There are 3 that you have to learn to memorize. Actually, there's 7. You're going to learn to memorize all the arms, and you need to learn to memorize the 30, 45s, and 60s, because those are the reference angles that are going to pop up the most. And they're really easy to remember. So 30 degrees is equal to pi over 6 radians. And 60 degrees is equal to pi over 3 radians. They're just the opposite. Okay? You could do 30 divided by 180 and figure it out. But 30 is pi over 6, 60 is pi over 3. These need to be memorized. And 45 is pi over 4. Because you can't spend the time converting those all the time. It will take you forever. And those are really easy ones. So the reference angle is 60 degrees in this case, but I can't give that as an answer. My answer needs to be in radians. So my reference angle is actually pi over 3, because that's 60 in radian measured. Okay? Now we could do coterminal by going 300 plus 360 plus 360 or minus 360, then convert them to radians at the end. Absolutely can do that. Or we could go 5 pi over 3 plus 2 pi or minus 2 pi. Okay? Which route would you do? Would you do 300 plus 360 minus 360 then convert to radians? Or would you take 5 pi over 3 and add 2 pi? I think 90% of you would do degrees. I heard from 2, so I'm going to say that that's 90% of you. And this is why I'm doing smiley faces from now on. You'll be like, hey, do you guys get this? And then you can do a check mark or an X. Ooh, there's so many options. It's great. I'm recording that. That's even more fun. Okay. So if we go 3, what did we figure it out to be? 300? Yeah. So if we do 300 degrees plus 360 degrees, we get 660. But that's a great answer. It's correct, but it's not a good answer for this question because it needs to be in radians. So 660 divided by 180 is what? 11 pi over 3. And then we can go the opposite direction. 300 minus 360 equals negative 60. And negative 60 is negative pi over 3. Could I have taken the 660 and added another 360 and got 990 and converted that and it'd still be coterminal? Yes. So how do you know which is the coterminal? Well, they'll give you options on the multiple choice and you have to pick them. Or they'll say coterminal angle restricted between certain domains and then you have to pick those as well. They have ways. They have ways. Yes, absolutely. That's great. So down to here. These are silly to think about, but people don't know how to put stuff in their calculator. So this is what I'm going to say to you. Up until now, your calculator has mainly been in degrees. The teacher could stand in front of you in grade 11 and be like, hey, so at the beginning, at the final, make sure we change your reset your calculators. Make sure you change it back to degree mode. That's not going to be the case. You need to be able to do degrees or radians. How do you know which ones you need to use? If it's in radians, use radians. If it's in degrees, use degrees. If you're punching in radians, use radians. If you're punching in degrees, use degrees. So then polynomials will come up, or other units from now on. They're like, what mode do I need to be in? You only need to worry about the mode of your calculator, and only need to if you're pressing the sine button, the cos button, the tan button, or the second sine, second cos, second tan. Okay? If you are not pressing those 3 buttons, or the inverses of those 3 buttons, the mode of your calculator does not matter for 1 second. So if you're just going like 2 pi divided by 3 and getting an answer, does the mode matter? No. If you're putting in y equals 3x squared plus 2x minus 7, does it matter? No. If you're putting in y equals sine 2x plus 1 minus 4, does it matter? Yes, because you press the sine button. Okay? So that's the only time the degrees and radians matters, is if you're pressing those 3 buttons. So sine of 30 degrees. What does my calculator need to be in? Degrees. So go sine 30 degrees. Now, if you don't know where to find degrees and radians, go to the mode button. I'm going to turn my calculator on because the battery's going to run out. That was funny, just so you know. Press mode. And right now it's in radians. Whenever it gets reset, it's going to be in radians. Okay? So I'm going to go to degrees. I'm going to hit enter. And then I'm going to go sine. The moment I hit the sine button, I think, what mode do I need to be in? Oh, I already changed it. Good. 30. Enter. And they went to 3 decimal places. So it's 0.500. Now, sine of pi over 6. Some people will say, well, that's sine of 30. So what's going to happen? It's going to be the same thing. So if you actually typed it in as sine of 30, it would be the same thing. If I type in right now, sine 5 pi divided by 6, it's not the same answer. Why? It's not in radian mode. And what did I just type in? Sine 5 pi over 6 radians. So I go to mode, change it to radian, and I go sine 5 pi divided by 6. Oh, good call. That was a really good laugh. I'm so glad I recorded that. Oh my god. So that's right. And now I'm going to change it back to prove that it was actually not going to work. Sine. So now I change it back to degree. Pi divided by 6. Stop it. It doesn't match, right? So it needs to be in the right mode. Now, could you convert pi over 6 to 30 degrees and put sine 30 in? Absolutely. It's not going to change it. But whatever you're physically typing in, your mode needs to be. Okay? So if you convert the radian to degrees and then put it in, all the power to you. Then have it in degree mode. Okay? Sine of 1.57, is that degrees or radians? Radians, because it doesn't have a degree symbol. So I need to go to radians. Could I convert that to degrees? Yes, but why? This is like a really easy question. If you're converting it to degrees, then plugging it in, you're making your life way harder. So don't. There are some times when putting it to degrees is not better. Often the times that people make it to degrees is when they have to draw it. Because right now it's like 5 pi over 3. Well, I don't know where to draw that, right? But if I convert it to a degree, I can draw it. That's when I see most of the time the conversions happening, is the drawing, because it's just easier that way. So sine 1.57. Now cotan. Cotan tells you what it is. Cotan of 70. So look, if I look at this formula sheet, it says cotan of theta. So if I ever am like, oh crap, I don't remember what to type in, I have no idea. Say, oh, I have a formula sheet that will tell me. It's wonderful. So I go cotan of theta. Oh, cotan of theta is 1 over tan theta. So cotan of 70, I'm going to type in my calculator as 1 divided by tan of 70. So some people get it all mixed up. They want to like go tan 1 over 70 or something. Just go to your formula sheet. It tells you. Don't mess yourself up. So this is just going to be 1 over tan of 70. But it's 70 degrees. And my calculator's in radians. Go back. I don't think I turned it. Nope. All right. Now, I get the whole odd letters. What's an odd letter? Really? Really? I know they're really not odd letters. I know that odd numbers are 1, 3, 5, ones that you cannot divide by 2. I get that. But if I said odd letter, what would you guess them to be? A, C, E. Thank you. I have a fight with this every year. There are people like, I didn't know that. It's like, but if I had to be like, you figure it out or you're not passing this class, I bet you'd get it. You would. And if you didn't, that scares me dearly. Nope, because those are just answers. Like these are literally the measurement. When we do unit circle, it'll make sense. So when you do the unit circle, what we're doing when we're finding that angle is we're finding the length it takes to get to that angle. So it's like a length. This is a measurement of length, not a measurement. It's like an X or Y measurement, not a degree symbol. So when you're finding sine of 30, you're finding the Y length at 30 degrees.